Multi-threaded applications are becoming more commonplace. Use the Threads and Task windows to discover what your threads are doing. To demonstrate that, I'm using this project, Debugging Threads and Tasks. Most of the code I'll be showing in this example will be in mainwindow.xaml.cs and in the workitems.cs file. I'll start by looking at mainwindow.xaml. And then I'll double-click on this first button. As you can see, there are a number of breakpoints already in my code. You may need to add breakpoints to match what you see in my code. This first method is here just to show the thread window. There's no code other than comments in this method. I'll press F5 to run the application with a debugger attached, and then click on this first button. To see multiple threads, you go to the Debug menu and choose this item, Threads. The default position for the thread window is docked to the top of the screen. You can see that I have a number of threads here, 6 threads running. Here's the main thread. You can tell that I'm in the main thread by the yellow arrow here. And I can see there are some other worker threads. Some of them have names, some of them do not. Some of these threads exist to support debugging. If you want to see a more real-world representation of the app threads, disable the VS host in the project. Let me show you how that works. Close this to stop debugging. Double-click on this property node inside the solution, and then click on my debug section. Down here at the bottom, there is this default setting called Enable the Visual Studio Hosting Process. VS Host is a helper exe that runs during your debugging sessions. It is created whenever you build a project in the Visual Studio IDE. Its purpose is to provide support for improved F5 performance and partial trust debugging. I'm going to turn off this check mark, close this window, and press F5 to debug again. Click on the button. Now I can see the threads that are used in my application, not the threads that are used by VS Host. I'll leave it at this state for the rest of my demonstrations. Okay, I'll stop debugging and we'll look at the next bit of code. The code inside this thread pool. In .NET, there are a number of ways of spawning a thread to do some extra work. The old school way of doing it is the thread pool. What I'm doing here is storing a value in this string on the UI thread, and then down here I'm saying the same thing on the UI thread again. And then here I'm asking the thread pool to queue up some work. I provide the name of the method, and at some point the thread pool thread, a worker thread, will come alive and go out and run the code in this open the files method. And in here I'm opening a content license txt file and a content html page.txt, and then I'm returning. So this code inside this method will be running on the worker thread, whereas the code here on line 39 and on line 45 will be running on the main thread, or the UI thread, since this is the WPF application. Press F5 to run the app. Click on the second button. You see I'm on this main thread. 8368 is its identifier. I'll press F11 to step through my code. Now I'm ready to run this code. I'm going to press F5. Notice there's no worker thread yet. We queued up the work, but before the work could be started, there's no thread in the thread pool, and it takes a little bit of time for that thread to get created. Meanwhile, my main thread continued to run, and it's loading this string value. Now when I press F5, you'll see that it hits my breakpoint over in the other method. Let me run that again. I don't know if you saw that. Press F5, press F5 again, and now I'm inside my open the files method, and you can see that that is running on the worker thread. And meanwhile, my main thread is idle. One of the problems with the way I implemented this code is that I have no way of waiting on the task to complete. The code that I sent for the thread pool, I have no way of waiting for that to get a result back. Luckily for me, my method open the files was returning a void. But if I was returning a string or a Boolean or some item like that, I can't do that using the thread pool. That's why Microsoft created the task class. Now, I don't have time to go over the task class in detail. It works a lot like the thread pool, but you can schedule a task and then wait for that task to complete. C# has the async keyword and the await keyword. VB has similar keywords in .NET 4.5. But I do want to show you one helper class, which is called the parallel class. It's down here. What I want to do is open a database connection, and then I want to send a number of email notifications. To do that, I have the code over here in this workitems.cs file. This first method, open database connection, has a thread.sleep for 1200 milliseconds. You don't want to have this code in production, but I'm using it to simulate some slow database openings. I'm going to remove these two breakpoints for the moment. On line 21, I have a method called send email notification that takes a string email address, sleeps for 1800 milliseconds, and then outputs information to the console. Now let's demonstrate what this does, and then I'll show you how you can look at the threads in action. I'll press F5 to run the application, make sure that I can see my output window, and then click on this button, Parallel Class. You see what happened down here in the output window? The connection opened, some of the emails were sent, and then about 1 second later, the rest of the emails were sent. Let's stop this code. I'll put a breakpoint back in here and back here. Then I'll go look at how I set this up to run in parallel. I used the parallel.invoke method, and then I specified each method that I want to call. The computer I'm using in the booth has 8 cores, so I made sure to have more than 8 items to send. Now I put the breakpoints in my code. I'm going to press F5 to run the application. Click on this parallel class button again. This is showing me the threads. Now if I press F5 a second time, you'll see the worker threads start coming in to do the work. I'm running on thread 1072. When I press F5 and hit my next breakpoint, I can see it's thread 9580 that's running that code. Let me stop the application, rerun it by pressing F5, and I'll show you a few other windows we can use. I'll turn off the thread window, and this time I'll go to the debug window and choose the parallel tasks. I'll also choose parallel stacks, and I'll choose parallel watch. So now I have windows that are dedicated to watching these parallel operations. Currently, I'm in the console right line in the connection open, the OpenDB connection, so I don't see any tasks in here. And I see I'm on one thread in workitems.opendb connection, and here I can see the watch information for that window. Now I'm going to press F5, which will move me to my next breakpoint. And here I can start seeing some more information. Down here in the parallel watch, I see all the email addresses that have been scheduled for that parallel operation. Currently, I'm working with task number 1. Up here in the parallel stacks window, I can see that there are a number of threads. This is a visual representation. There's 8 threads currently, and they're all being scheduled to run in these different areas. Send email notification, send email notification. And then up here, I can see that I have one active task that's assigned to this thread. I have one scheduled task, and I have a number of threads that are currently blocked. Now I'm going to press F5 one more time. We'll move to task number 3 down here, and I can see a lot more of the tasks are now active, ready to go. I can see I'm working on this thread down here with db.explorer.ca.com, and I can see I'm over here in this item as far as the parallel task windows go. Writing multiple threaded applications is not easy, but these tools, the parallel tasks, the thread window, the parallel stacks, and the parallel watch window will help you be a better multi-threaded developer.